Okay, if you guys can turn to page 26 in your packet, we're going to be doing ellipse and hyperbola review. Okay, so again, we're doing a quiz review today. Tomorrow in class, students who are taking the quiz, if we choose to take it Thursday, we'll have a testing environment here in the classroom. So for those of you who are opting to take it Friday, you should just sit quietly and work on something, either a quiz review worksheet 2 that I'll have available to you, or you can work on something else, but you have to be quiet to allow for the other students to be able to take their quiz. Okay. A couple of things I want us to add before you guys try through these problems. Thanks. First is, if you look at number 3, sorry, I did not check the graph before I printed it out, so it's not showing you where those locations are. If you guys can highlight those order pairs, those important points, 4, -1, 1, -5, 7, -5, and 4, -9, and that should allow you to count and find your A, your B value, as well as your center. Okay, so copy that down. Sorry about that. This is number 3 on page 26. And then second, if you guys can go to the back of your packet, and for number 7, I want you to add number 7, identify conic shape. You guys can write down those 4 equations. You'll see something like this on the quiz, where all you need to do is, you don't have to show any work, you just have to identify what shape it is. Is it a circle, ellipse, parabola, or hyperbola?
We do get a calculator, that's right.
You do get a calculator. Another thing that I want you guys to study with or study is ellipse and hyperbola formulas. So this is on this very back of your packet, page 32. Make sure that you know your standard form for your ellipses, and also know that your equation for c squared is a squared minus b squared. Meanwhile, for hyperbola, you got to deal with slightly different equation, a squared plus b squared equals c squared. Know the standard form for hyperbolas, and also know how to create your asymptote equations. Okay. So again, the big distinction with A's and B's with ellipses is that with ellipse, your A and B value is dependent on which is larger, right? The larger value is your A, the smaller value is your B, and whatever the A value is under will tell you whether to go left and right or up and down. If A is under the X, you're going to go left and right. If A is under the Y, you go up and down. For hyperbolas, we don't care about which one is larger. We care about which one is first, which one is positive. So whichever value is positive, whichever comes first as a positive term is going to be your A value. So if your X is positive, then your A is going to be moving left and right. That means you're dealing with a horizontal axis, okay, or a horizontal transverse axis. If your A value is first and under the Y value, sorry, if your Y is first and positive, that means the number underneath is A value, and that's going to tell you how many units to count up and down from the center. Then you'll be dealing with a vertical transverse axis. Okay. All right, so let's start with number 1. I'll show the steps as you guys have a chance to try each. you know you're dealing with an ellipse because your x and y squared, they're both positive, they're both the same signs, and they have different coefficients, so you know it's not a circle. Start grouping the x's together, then the y's, and then the constant on the other side. You know you got to deal with GCF for the x's and GCF for the y's. And then gradually set up for completing the square. Factor out a 9 for the x's, factor out 16 for the y's. Complete the square, b over 2 squared. Careful, if there's something outside the parentheses that indicates that the spaces on either side are not going to be equivalent with the same number, so you'll put 16 in the first space, but on the other side it'll be 16 times 9, right? Because there's that 9 impacting the true value of that constant on the left side. Okay, if any step doesn't make sense, be sure to ask so I can clarify any steps for you. Right side cleans it to be 144. Factor multiplies to be 16, adds it to be 8, be x plus 4, x plus 4. Multiplies to be 25, adds it to be negative 10, be negative 5 and negative 5. All right, getting closer towards standard form. To top it off, we want that right side to be equal to 1, so we'll divide everything by 144 to get that right side to show as 1. Okay, reduce between 9 and 144, reduce between 16 and 144 to get a clean value below the x and below the y so you can identify your a and b values. Remember with ellipses, your a value is the larger, right? A is the larger one. For those of you who are working ahead, that's fine. I have the key loaded on my website. You can check it if you like. Yeah.
Do you know that the A's go horizontal or the B's go vertical?
Right. So first off, we know that the A squared is 16, right? Because we know that A is a larger value. And then we know B is 3, okay? But now we always can look at what variable is sitting above. Okay, so whatever's sitting above is going to tell you which direction to move. So because 16 is below X, we associate X with left and right, so that's how we know to move left and right.
So the bigger number.
Well, the bigger number is A, but we also know A is moving left and right because it's below the X.
And if A was below the Y.
Then you're going to go up and down. So whatever number is below the variable, that's going to tell you which direction to move. So whatever is under the X, you're going to move left and right. Whatever is under the Y, you'll move up and down. That also goes for hyperbolas. So there's that consistency between ellipses and hyperbolas. Whatever variable is above the number is going to tell you which direction to move. So I like to have these directional reminders so that it's good visual, so that I'm not accidentally making a mistake when I'm counting. Remember, your A and C will always be in the same direction. So if your A is moving left and right, then your C is also moving left and right. Okay, any question with one? Move on to number 2. Tangent just means that your ellipse will touch the X and Y axis. And if you know that it's just going to touch, skim the surface of those lines, then you can have an idea how your A and B value is going to look, and you can sketch your ellipse as well. All right, number 2, write the equation of ellipse in standard form, which is tangent to the X and Y axis, and the center is -2, 5. Okay, we know where the center is. We know that our ellipse will be formed. We know that the edges will just skim the surface of the Y-axis and also of the X-axis. So we know it will go as far right as the Y-axis, and it'll go as far down as the X-axis. And just for this information alone, we should be able to kind of figure out the rest of it, right? We know that the distance here is going to be longer along the vertical. We're expecting our A value to be vertical and our B value to be horizontal. Major axis is along the vertical. So you know that your A value is going to go under what? The Y, right? Okay. Mhm. I do, yeah. I'll have a limited copy. I'll give the worksheet too for those. Well, I'll print out some more tomorrow, but I show of hands of those who are thinking of taking it tomorrow. Okay, let me give you those. And for those of you who are not, I'll give this to you tomorrow. Is that, I have them. I'll make some more copies for the rest of you. This is worksheet 2, so I've made an additional copy. Any questions with 2? Okay, number 4, hyperbolas now. So we have to think about how we find our A and B values, right? We no longer care about which one is larger. We care about which one is first. Your A is always first for hyperbolas. Notice the 4 is under the Y. 4 is associated with the 2. So you know you're going to go up and down 2 units. And also you know that it's going to be a vertical orientation. Your 49 is related to the 7, is below the X, so you're going to go left and right. And then your C value will always go in the same direction as your A value. Yeah.
So how do you find the asymptote?
Okay, how to get the asymptote? So your asymptote, you're always going to take the Y first, equals, and then the X component. You're just going to take it down from your original equation. The only thing you have to figure out is that slope, 2/7. So the way you get there is you start at the center, and you go to the upper corner of your box, and you do rise over run. So it's always, you just always count. So up 2/7. We need 2 equations because we have an X that both, one is positive, the other is negative slope. So just put a plus or minus in front of the slope. Yeah. So transverse is the axis that connects the vertices together. The conjugate is the axis that connects the co-vertices together. Yeah. So think of the transverse axis as your main axis. It's not necessarily longer, but it is the more important one. It includes it has vertices at its endpoints. All right, any questions with 4? For hyperbolas, we always have to make the decision in terms of which will come first, right? So you always compare your x squared and y squared. Whichever is positive is what you want to lead with. In this case, the x squared is positive, so we're going to have the 16x squared. Group the x's first, then the y's. But if the y's were positive, then we got to rearrange the order. Then we will want the y's to be grouped first, and then the x's. Good. Any questions about this? Getting from general to standard form for number 5? Careful with the y's. When you factor out a -9, you know that you got to do something additional because you're dividing by a negative. You're factoring out a negative, so the sign has to change. So that's the additional complexity that we didn't see with ellipses, that when we're dealing with that second factor, that minus sign is going to throw a little bit of a curveball there. We got to make sure we divide by -9, and we need that to be a positive 6y inside. Yeah.
Is it okay for the correct case to be still running -1 plus or minus 5? Call it -3.
What side?
Yeah,
Which problem?
for 5, does it matter if you write it right close to them out, or you write -1 plus or minus 5?
Oh, yeah, that's fine. All right, number 6. And we can start putting information onto our graph. Transverse axis is the main axis. It's the one that's going to connect from vertex to vertex. So when it says endpoints, those endpoints are your vertices. And if you have your vertices, both of them, you can count to the center, count to the midpoint, because what's exactly between the vertices will be the center. If you can locate the center, then you can count from the center to the vertex to get to your A value. They're also telling you that the conjugate axis is a length of 6. So conjugate axis is going to connect from covertex to covertex. So if I have the full distance from covertex to covertex, then you know that the center is somewhere in between, and that your B value is going to be half that. So you know that if your full axis is given, you know half of it will be your A or your B value. In this case, it's B because conjugate is going to be related to your B value. So your A value is going to be 3, your B value is also 3. Find your C value. The vertices are left and right of each other. So we know that this is going to be X is going to come first. Okay, any questions about number 6? Okay, does anybody still need to look at number 6? All right, number 7. Identifying conic sections. Okay, so we only care about the x squared and the y squared. Okay, we should be able to determine. We don't have to work anything out. We can determine just by looking at the x squared and y squared whether we're dealing with hyperbolas, ellipses, or circles. So for part A, x squared and y squared, same signs, different coefficients. So if we're dealing with same signs and different coefficients, what does that tell you? Not quite. It's an ellipse, yeah. A circle would be, a circle would be same signs and same coefficient. Yeah, everything has to be very restrictive with circles. So A is just going to be ellipse. Part B is easy. Only y is squared. Parabola, yeah. Part C, x squared and y squared, same signs, same coefficients. This is a circle, yeah. Okay, part D. What's the giveaway here? Different signs. Does the coefficient matter? Doesn't matter, right? Because as long as it's different signs, we know it's going to have to be hyperbola. Let me check your quiz review, 26 through 28.
DJ, you got a cowlick, bro. You got a cowlick. What?
Oh yeah, it's
I said you got a cowlick, bro. What? You got a cowlick. Of course.
Whoa.
I mean, it makes sense because he's a white person. He's like one right through the. I just thought little like part of hair that's like synced up. Cowlick to him.
Oh. No, it's not me. Wake up. It's like it stays like that.
No, see the picture, no. I just tell it.
No, like they call it cowlick.
Yes, cowlick.
I've never heard that word before. They don't say about cowlicks. It's cowlick. Cowlick. It's a cowlick. That's what you do. The white culture. You know what they call piggy?
Huh?
They call it piggy taste.
I don't even know what you said.
Chicken. Piggy taste.
Chicken.
Chicken. You know what chicken is? Like piggy taste. Don't ever eat.
Why do you know that?
Yeah, don't ever eat them. See, you learn something every day.
Why do you know that, and why were you surprised I didn't know that?
Oh, because Little bit off. Say.